Hello, everyone, and thank you for joining us today for our HashiCorp Solutions Engineering Hangout, hosted by Sean Carolan. Today, Sean is going to show you how you can move your VMware workloads to Nomad without having to rewrite your applications. I also want to note that the Hangout is recorded, and the recording will be made available after post-processing, usually within about a day or two. I'll email it out to all of you. The demo will be about 20 minutes, and then we'll allow up to 30 minutes afterward for questions. So please go ahead and submit your questions throughout Sean's demo through the GoToWebinar portal, and then we'll answer them at the end. So with that, let's go ahead and get started. Sean, let me give you the screen, and you can take it away.
Thank you, Amanda. All right, let me go ahead and to see if I can share one window. Is that possible?
I think so.
Yeah, let me just move this over to the right window. Okay, that looks better.
Yeah.
And you should be seeing.
It went away, Sean.
Slide did it? Okay. What are you
it's
seeing
all purple
now?
right now. Is it supposed to be only blank purple?
No.
There we go.
Okay. I'll show the whole screen. That'll be easier.
Okay.
How's that look?
Yeah. You're in the vSphere client.
Okay, good.
Okay.
Excellent. Excellent.
Mm-hmm.
All right, great. All righty. Can you see my slide deck?
Yes.
Okay, perfect. So the title of this webinar is called Move Your VMware Workloads to Nomad. And you might be curious about the name. So what is Nomad? Why is it called Nomad? The dictionary defines a nomad as a member of a people having no permanent abode and who travel from place to place to find fresh pasture for their livestock. Nomad is a bit like that. It's able to find resources for your servers and your workloads. So if you think of your servers like cattle instead of pets, and you're managing large groups of VMs or machines, the Nomad could be like the shepherd that moves them all around and puts them in the right place. So Nomad is a workload scheduler. It's a modern, lightweight workload scheduler. What is a workload scheduler? In many environments, this is a human being. This could be a system administrator. So I used to be a systems administrator. And when the application team wanted to deploy code, they need some compute and network and storage resources to be able to run their applications on. This is where the operations team usually comes in. You're probably familiar with that age-old story. Someone submits a ticket, then the ticket goes through several stages of approvals and different processes, kind of like a pinball bouncing around in a machine. So the request bounces around until all the right pieces are in place. The app's deployed onto the servers and left up and running until the next maintenance window or patch or upgrade or bug fix. Sooner or later, you're going to have to do something with those machines. Maybe you'll have to replace them or rebuild them. But unfortunately, many legacy applications, they're just not that suitable to a modern containerized world. And so we're stuck with these legacy VMs that maybe aren't quite ready for the migration to cloud or containers. What can we do with them? Nomad can actually work as a modern workload scheduler, even for legacy apps. So we're going to show you today how you can take a legacy app out of VMware and move it into Nomad and get some of the benefits of a modern workload scheduler. So in the old days, the human beings would do it, or maybe it's the modern day for some of us. This is a step forward in that now we're letting the machine actually automate placement of our CPU, disk, and memory resources. So instead of having a human pick the least loaded machine to put the workload on, we're just trusting our Nomad cluster to place all our workloads for us. Nomad supports both containers and traditional VMs. So you may have heard of some of the other workload schedulers out there. There's lots of ways to run containers, but not a lot of options if you have traditional VMs. How can I get the benefits of a modern workflow and pre-built images, golden images, and immutable infrastructure if I'm still using VMs? So Nomad supports both. It actually supports several different types of workloads, not just containers. Nomad uses simple job config files. We don't want this to be difficult. So when you run Nomad, you have a really simple job spec. You submit it to the Nomad cluster, and then Nomad will go ahead and automatically carry out that build for you. We'll show you what that looks like in the demo here in a little bit. It's automated and efficient. Humans aren't the greatest at placing workloads. I used to manage a VMware cluster once upon a time, and it was sort of a mishmash of different types of machines and different hardware generations. And it was always fun to try and figure out, where do we put the new customer application? Where do we deploy it? And the sysadmins would want to cram as many customers onto a single machine as possible to be efficient. But sometimes, the customer side of the house would say, no, we have to have dedicated, a special machine for this one customer because they're special. So that app needs to run over here. And so we would do that, put all these machines into different places. What if you could automate all of that and never have to think about it? You just throw your job file at Nomad, and a few minutes later, everything you stood up just appears. Nomad supports rolling deployments. You can upgrade or change things on a few machines at a time and then roll it across your entire fleet. So this is a safe way to do upgrades without trying to change the whole world on every machine at once. You can also do canary or blue-green deployments. This is where you've got version 1.0 of your app over here, and you're ready to spin up version 1.1. Wouldn't it be nice if I could test version 1.1 alongside version 1.0 and make sure it works before we actually pull the switch and make the change over to 1.1? So blue-green deployments do exactly that. You're standing up a whole other instance of your app with the newer version. When you're happy with it, you fail over to that new version and shut the old infrastructure down. Nomad also has automated failure recovery. So when you spin up a job, Nomad's going to take care of the life cycle of that job. If one of your VMs or your workloads crashes for some reason, Nomad can spin that resource back up on another cluster or on another machine. Nomad is multi-cloud, and it also supports hybrid environments. You can run Nomad on-prem in your own data center on your hardware, or you can run it in the cloud, or both. And you can even kind of extend Nomad infrastructure across different clouds or different data centers. Why would I choose to look at Nomad if I'm using VMware? So on the left is a shot of the vSphere client. It's probably familiar to many of you. You'll click your way through and build things, and it's got a nice GUI and lots of great features. On the right, we're doing things with code. So this is a more automated workflow on the right side. The first reason you're probably here, or why you might like to look at Nomad, is because you could save money. Nomad is open source software. So you can download it, you can use it for free. It's got a lot of great features. Now, of course, we also have an enterprise version, but we don't cripple or limit the open source version in any way. The enterprise version mainly focuses on things like collaboration and governance, things that large companies and organizations tend to care about. And of course, we offer commercial support if you need that. But everything you see today in today's demo will be all done with open source software. So the monetary cost to you is zero. Maybe you need to support mixed environments. Many companies are engaging this journey on their way to the cloud. And on the way there, they've got to support what we call a hybrid environment. We have some of our resources running in the data center, some of it's in the cloud. We want to be able to kind of freely flow back and forth between those environments while we move to a new way of doing things. So Nomad gives you a common platform for scheduling different types of workflows that it decouples the system administrator a little bit from the folks who are, doing applications. So you have the infrastructure team, they maintain the Nomad, hardware, and then app teams can easily come up and provision what they need, even in mixed environments. We can help you move legacy applications to the cloud. So you might have an app that is running in a, VMware VM, and it's never going to get upgraded. No one has budget or time to rewrite or upgrade this application. I'd like to be able to just move it. I want to get it out of the data center. So this is another use case for Nomad. You can actually take a VMware image file, a disk image, and run it directly under Nomad. We'll show you how that works during the demo. Nomad helps you get maximum efficiency from your hardware. Sometimes we call this bin packing. I've got a couple of slides to talk about that. But it's the way that we stack machines onto their hosts in an efficient way. So not just machines, but it can be workloads or containers or what have you. How do we carve up our memory, CPU, and storage in a way that is efficient and effective? We also have automated machine placement. So again, to reinforce that fact, Nomad takes care of putting the machine where it makes the most sense. And you know what? Nomad's really good at this. There's no need for a human being to waste their time trying to figure out the best way to stack all these blocks together. Nomad also enables self-service provisioning. Now, instead of playing ping pong with service tickets and emails back and forth between the network and storage and ops teams, you codify everything you want out of your job in a simple file, and then get someone to review it and deploy that file into the Nomad cluster. So it can greatly streamline just the act of provisioning within corporate environments. Let's talk a little bit about Nomad's architecture. Nomad ships as a single binary file. So this binary file is written in Go, Golang. It runs on any platform, so it's pretty much OS independent. I'm going to run it on some Linux servers today. And this single binary can act as either a client or a server. You see here is a small Nomad infrastructure. We have servers, which are the brains of the operation. They handle all of the math and the figuring out the most efficient way to move your workloads around. And then you have clients. These are the worker bees. Clients are where you're actually spinning up new containers or VMs or Java applications or whatever process you want to run. And these machines all form a big cluster. So you don't have to think too hard about what type of hardware it is. It's okay even if all of these machines are different. They can all have different CPUs and different amounts of memory, different amounts of storage. You can just rope it all together into one giant cluster and Nomad will manage it for you. And usage is really simple. You download the binary, make yourself a config file, and you run it. And that's it. That's the entire setup. And then Nomad will automatically form this cluster of compute resources, and you can start running your workloads. So it's very, very easy to get started with Nomad. Let's talk about bin packing. What is this thing, bin packing? You might have heard this term before. Bin packing is a sort of a math challenge where we want to theoretically figure out how to pack these bins or containers into a larger container in the most efficient way. So let's say I have some different shaped blocks, and some of them might even be shaped a little weird. And they're different sizes. And I need to figure out how to efficiently pack all of these things into here in the most effective way. So I might, carve off some space for a big one, and I can have some smaller ones. And we're packing the, even the weird shaped thing in here as effectively as possible. And the goal is leave as little, empty space as possible. So that's basically bin packing. We're taking different size, different shape workloads, different VMs, if you will, and we're sticking them all onto the same server. Now, what happens when you leave bin packing to humans? You end up with something like this. So this is actually me playing Tetris, and you really want to try and pack the blocks in as efficiently as possible. Can you hear the Tetris music? I can hear it. Dun, 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 dun. There it goes. No! Ah, see, that's not very efficient. And if you have any sense of OCD, you know, it really bothers you that there's this empty space down here. So another way to try out bin packing on your own at home, go and get with your spouse or significant other and do the dishes together. You will get a lesson in bin packing because everyone has their own way of kind of filling the dishwasher up. We're going to let Nomad do it for us. So that brings us to our live demo where we will take a VMware VM and follow it on its journey as it moves over to the land of Nomad. So our story begins here in the vSphere client. You can browse around and see all your VMs. And each virtual machine in VMware has got a folder here somewhere in the data store. So I'm looking at this Ubuntu VM. And these are the different parts of a virtual machine. So here's the memory. You can see it's got a little memory icon on it. And it's a template file and a log file. The thing we care about, though, is this VMDK file. This is the brain of the server. It's basically the disk. So it says here it's a virtual disk. This has got the OS. It's got our applications on it. It's basically running everything that we consider to be the server. Okay. Now, when we spin it up, VMware provides some virtual hardware for that OS to run on. So what we're going to do is perform a surgery where we remove one of these VMDKs. We're going to take it out of VMware and run it in Nomad. So your first step will be to copy your VMDK. Highly recommend you don't do this on a live machine. Make a snapshot first. It's safe to do that, right? And you can build a copy and have a backup. That way you can work on the backup and not touch the actual disk file. A couple other things you might think about doing with your VMDK. So I've actually downloaded one. Here's our VMDK file. We've got it here on our desktop. We want to set it free. You can fly away, little VMDK. Actually, it's not quite that simple. So there's some other things we need to do with this disk file to prepare it to run in Nomad. Now, it might run out of the box, but if you want to make this more efficient, you probably want to start off, first of all, with shrinking the disk, okay? Shrink your disk. If you have a huge VMDK file, like it's like 60 gigs, I bet you could carve that down. Try to get it down to 10 or 12 or 4. Managing gigantic disks is not that fun, especially when you have to do it with Nomad. So smaller VMDKs are better. You can use a big one, but just know that every time you deploy a new instance of this, you're kind of having to pass this giant image around. Second thing we want to do is make sure we have a network driver that can run on the new hypervisor. Usually the default drivers will work just fine, but it's something to look into, especially if you're running a really old VM. And thirdly, and this is kind of important, we got to think about local storage. What are we storing on this VM? Do we really care about it? Is it stuff we need to keep? And if it is, you need to figure out how to move that stuff off onto a network drive. When we move our VM from VMware to Nomad, we're not just copying the VM, we're creating a golden image. So what we're going to do is create a brand new, fresh image, or use this as a fresh image, and then deploy new instances from it. And that gives us greater power and the ability to perform rolling upgrades and do all those cool features that I mentioned earlier. Let's do a little quick diagram of how this is going to look. So I've got my disk image, and I need to move it to, so VMware is over here, right? And then we have Nomad over here. Nomad is going to consist of clients. These are machines running the KVM hypervisor. And then we have one or more servers. Let's call these servers. And these machines are all kind of in communication with one another. And the servers know what's available in our pool of CPU, disk, and memory. My operator here, they take the VMDK file and you want to upload it to a file server. This can be any kind of file server. Even a simple web server will do, or you could use Artifactory. The basic idea is get the VMDK out of VMware and copy it up into a file server, optionally doing those other steps that I mentioned. Now that we can serve that VMDK image to our Nomad infrastructure, we're going to submit a job. So we send a job to Nomad. Nomad reads our job spec, and then it looks out here at all of the available infrastructure to see what's available on these machines here and how much space do I have left. So I might be using part of this machine, and I need to place, let's say, a smaller instance, like that size. So Nomad's going to look and say, well, this machine's not quite full yet. We're going to put another workload onto it. We'll place it there. And then it will go ahead and run that job, fetch my VM, and then run it right here. And then if I need more of them, I can stand them up on different machines for high availability. Nomad is smart, so it will use your job file to determine the best place to put all of its workloads. So that's basically the architecture. That's what we're going to do here for the demo. Go ahead and hop over to my demo environment. All right, so we rescued the VMDK file. We've moved it into our image repository. Now we can pull it into Nomad. Right now, this Nomad cluster is empty. So I've got Nomad running on a server, and there are two clients. You can see here I've got one server, two clients, and here are some previous jobs I ran earlier. You can get a lot of info about the client and what type of hardware it's got. So Nomad crawls through and takes a nice inventory to see how much horsepower have we got, what type of CPU is it, what's the total compute units you could allocate. And it does the same thing for memory as well, and disk. So all that info is in here. You can access it through the UI or through the command line. Let's hop over and take a look at those three machines now. So I've got the two machines up here on top, and they're running the HTOP monitor, so we can watch the CPU and disk. And then down here on the bottom is my Nomad server, where I'm also running my Nomad commands. Nomad status shows got nothing running right now. I'd like to kick off a job. So I'm going to kick off a job, and then we'll go look at the job, and I'll show you what it's doing, and we'll come back and see what it did. So to run a job, I simply do Nomad run. I've got my job specs here in the directory. I'm going to run a large web app. And you might have noticed the CPU spiking up here on the right. Nomad has gone and assigned that job to this machine over here on the right. So it's fetching that disk image and getting ready to run it. Let's look at the code that is being used to run the job. This is a Nomad job spec. It's written in HashiCorp config language, also known as HCL. It's pretty easy to learn, and it's basically the same language that's used for Terraform and our other products. At the top level, we have a group, and I've called my group VMDK. You can name this whatever you want. Inside the group, you have tasks. And at the very top level, there's job. So you can have a job with multiple groups, each group containing multiple tasks. So it's very flexible, and you can build groups of machines. And Nomad is smart enough to move, if you have multiple machines in one task, it'll try to spread them around the compute cluster so they don't all get put on one machine. These are my resource constraints. I call this a large because it gets 4 gigs of memory and 2048 CPU units. You can also have Nomad automatically open some ports for you. So the ports I care about are my web app, HTTP, and SSH. Note that I didn't have to give a port number. Nomad's just going to pick a high-numbered port number and attach it to my app on that machine so that the port forwarding will let me write through. Down here, we're creating a service and health check. And for that, we're using our other tool, Console. Console is a service discovery tool. It's really easy to use. And Nomad integrates directly with Console. So the service defined here is a web port, HTTP. And the health check is going to look for our home page, our index page. And then we're using some tags here to tag the service and also to let our load balancer know that we registered the service. So I'll show you the load balancer in a moment. The driver is QEMU. This is the virtual machine driver. It's free. It comes with, most any modern Linux system has it nowadays. And the modern versions of QEMU can actually run unmodified VMDK files. That's what makes this so easy to migrate. I just took that VMDK disk, copied it out of vCenter or the vSphere manager, and put it out here and let Nomad run it for me. Now there was a little bit of configuration to make it work. We need to tell Nomad where to put the disk image on the client. So that's what this is for. KVM accelerator is super important. When you're running virtual machines, you want to make sure that you have the hardware-assisted virtualization available to you. And if you own your own hardware, you can just turn that on or check your BIOS and make sure it's turned on. If you're running in the cloud, however, you need to ask or find out from your cloud provider if they support what's called nested virtualization, or in other words, running a VM inside of a VM. Yes, it is possible to do it. You can run your VMware VMDK file inside a VM on your cloud provider. Then we feed it some arguments. So these are arguments to the QEMU command that's going to run to spin up our VM. First is the network driver. We support about 8 different network drivers. I picked D1000 because it's very widely used and works on almost any Linux system. And then over here, we're telling Nomad what ports we want to forward through to my web app. So in other words, on each client, there's a little private network, and the VMs are getting IP addresses and running on that private network. These port forwards pass traffic through to my application or to my SSH. And it's all done dynamically, so I don't ever have to worry about assigning a port by hand. And finally, this is where we store the artifact. You can use any file server for this. And what Nomad will do is fetch this VMDK file when you spin up new workloads. And under options, we have a checksum. So this checksum will change anytime the image changes. We recommend that you continue to update that image and patch it. And that way you can always have the latest patches available when you spin up your workloads. And you have a checksum that matches so that you know that unauthorized changes haven't been made. So that's a quick tour of the job file. I put these on GitHub. We'll share the link at the end in case you want to borrow these and use them on your own. And we'll head back over to the demo. Let me just check and make sure there's nothing in chat. Amanda, are we good? Still good on audio?
Yep, we're still good.
Okay, great. We'll carry on. We've submitted a job and it's running. So now I can see it with Nomad status. And I can dig down deeper. Nomad has a nice autocomplete. Get a lot more info about my job and what it's doing, where it's running. So that tells me the node ID. And you can dig even deeper if you look into the allocation here. It'll give you a history of the recent events, tell you if it's running, and also how much CPU memory and disk it's got, and any ports that you've decided to expose to your service discovery tool. That is over here. So we're using Console, another HashiCorp tool, for service discovery. Anytime I spin up a new instance of this VM, it's going to automatically register itself with Console with a health check. So here's the health check. And I can actually use this with different load balancers. One of them is called Fabio, another great open source tool. And Fabio is automatically routing traffic through to the back-end machines. I don't have to think about any of this. It just happens automatically. And then here's the application that we deployed, the Meow World app. So I just got one machine so far. Let's do some more bin packing. Okay, we're going to stack some more machines into this Nomad cluster and see what happens. Now remember the first one I spun up it was large. It's asking for 4,096 megs of memory. That's more than half. So what that means is there's no way I can ever fit two of these onto one machine. Therefore, the next one's probably going to be placed on the machine on the left. Let's try it. We can always do a dry run too, in case I want to see what would happen. You can do plan job, and let's do large one. Oh, job plan. Sorry, got a little dyslexic there. All right. So what Nomad is telling me now is I would have created this. Yes, we have enough compute capacity. Let's do it for real. And now you see the CPU on the left side spiking up because it had to put it there. That was the only place that there was room for that size of an instance. And we can repeat this process. So let's add some mediums to the mix now. We'll do medium 0. And then medium 1. And we can start sticking some smalls on here as well. We're going to cram this cluster as full as we can possibly get it. Okay, another small. I'm going to pause here because I think we're getting pretty full. We'll do small too. And oh, a warning. So this means that we have reached capacity. And if I were to deploy this, it would exhaust the memory of the cluster. It'll still let me do it. And it will wait until we add more compute capacity to deploy that. So it's safe to run this. Just know that it's going to sit in the queue and it won't come up until we either add more machines to the cluster or spin down some of the other workloads. But we're not done. We can fill in all the cracks between the smalls and the mediums with tinies. So let's add some tiny machines now. And we'll just keep adding tinies until we run out of space. How much load can we put on this poor little cluster? It hasn't given up yet. I think I ran out at 6 last time. Yep, okay, that's it. I don't think we're fitting any more workloads onto these machines. So this is a very, very like CPU and network intensive activity to spin this many machines up at the same time. We can watch the progress over here. Here are all the different jobs that are in the queue. And the Nomad GUI will give you a nice overview of what's happening and what stage things are in. And you can drill down as far as the task group and even the specific client. And these are the IP addresses or the ports that actually will be exposed once that machine is up. It's going to take a while though. I would say it could take another 8 to 10 minutes for this cluster to stabilize itself. And if I wanted to, I could just add more machines so that small 2 and tiny 6 here could finish building. Or I can clear off, some of the larger instances to make room for those. The choice is yours, and you can even automate that stuff too. So if you wanted to, you could trigger an alert, based on the cluster being almost full, and then automatically provision new clients to run those workloads on. So a lot of different ways you can use Nomad. It's meant to be easy to get started with and very flexible, well suited to workloads that don't require state or that you don't expect to keep running for a really long time. So what I mean by that is if you had a machine in here and there was a lot of important data on that machine, I would probably not do it this way until you could get that data off into a shared drive. You want to kind of separate the app from the data so that you can do this ephemeral, job-based workload scheduling. Instead of thinking of your servers as these, machines that stay up and run forever, they're just instances of an image, right? So that brings us to the end of the demo, and I'll share the sample code at the end. If you'd like to learn more about Nomad, you can just visit nomadproject.io. And we've also got a great tutorial site up and running now. It's called learn.hashicorp.com. It's self-paced and it's free. So if you'd like to learn some more about Nomad and play around with it, you could try these tutorials here as well. And I think with that, we can open up for questions.
Awesome. Thank you, Sean. So we do have some. Anyone with questions, please go ahead and submit them. So Sean, first question, how would you say Nomad compares to Kubernetes for this use case?
That is pretty much an apples and oranges comparison. They really don't compare. Kubernetes only runs containers. So you can't feed a VMware disk image to Kubernetes because it just wouldn't know what to do with it. So they're completely different. Now, where there is an overlap or some sharing of the same types of features between Nomad and Kubernetes is that both of them can spin up containers. So if you just want an easy way to run Docker really fast and efficiently, you might give Nomad a look. In fact, we did the million container challenge with Nomad, and that's here. And we're able to achieve very, very fast results, with clusters. So we basically spun up 1 million containers inside of, I believe it was 5 minutes. Yeah, you can read the results here. So if scale is an issue in your world, definitely give Nomad a look. Also, if mixed workloads, you have some stuff that may be a Java app or a VMware VM, Nomad supports several different drivers. Here's the one that we use today. So QEMU is the generic virtual machine runner. We also support Docker, like Kubernetes. And you can even do things like run a command or your own special app, anything you can really run on the command line. There's also a built-in Java driver. So the similarities with Kubernetes would end with Docker, and then we support all this other stuff as well.
Thanks, Sean. Okay, and on that Docker note, someone was wondering, like how would the workflow change if they wanted to run Docker containers?
Instead of Kubernetes? Or
Yeah.
instead of, or moving from VMware to...
Yeah, so like this demo, but doing, Docker containers instead.
Well, the answer is it depends a lot on what you're running inside of that VM. If it's just a simple Apache site like I have here, pretty easy to move that into a container. Now, if you've got a big, heavy-duty legacy app that's got a lot of weird moving parts inside your VMware image, you're going to have to think about how to break that down and put it into containers. Now, the sort of ham-fisted approach is to shove the entire OS and just copy it into a container. Then you end up with these gigantic, multi-gigabyte containers. Really, you want to try to keep your containers small and efficient and have just enough OS on them to run, your application. But it is possible. So if you absolutely have to move from traditional VMs to containers, you can take the whole kitchen sink. In other words, you can move your entire monolithic app into a gigantic container. Don't recommend that. You should think about ways to kind of refactor it and break it down into smaller parts.
Yep. Okay. Next question. Someone's wondering, do they need to install console prior to Nomad?
No, you don't. But let me show you the parts that you would miss out on if you don't use console. I created those VMs using this job file. If we didn't use console, we miss out on this service and health check. So the point at which you'd stop if you only had Nomad was you would get your which one did I run first? Let's go look at one of the larger jobs. Okay, one of these should be done by now. I run this, and then it generates these. So you would have to write your own system or figure out how you wanted to access these and use them. Whereas with console, they can automatically register in this service catalog. Definitely recommend taking a look at console if you decide to use Nomad, because they really, really work well together. And that's what allows the load balancer to sort of automatically find all of my stuff. You don't have to use Fabio either. There are other options for the load balancing bit. You can use HA proxy, Nginx, anything that supports a sort of service discovery method of routing, you could use.
Awesome. Okay. And next question. So someone's asking, are there any particular VMware legacy apps types that are not a good fit for Nomad?
Yeah, it's really going to boil down to the network driver and the hardware drivers on that machine. So if you go into vSphere, and you look at a VM, this VM has some kind of a virtual network card that lets it talk to the host. And so it's possible that you could have a VM that's so old that it's using a legacy network card that's not supported. But E1000 is a pretty safe bet. That one I used in the example there comes with most every Linux system for the last at least 15 years would support the E1000 driver. And you can also sometimes upgrade the drivers. Main advice I'd give there is, if you're not sure that legacy app is safe to migrate, make a copy of it. Go ahead and put it into a sandbox or a lab environment, and try upgrading all the network drivers first. The way you could do that is to either install your OS's virt.io driver. So on these machines here, I believe there's virt.io. This is a virtual network driver that works really well. But if you don't have that available, you can fall back on E1000. It's not on this machine, but I have it on the clients.
Awesome. Okay. So now someone's wondering, does Nomad support stateless workloads only, or have you seen use cases where there is support for stateful workloads as well?
If you wanted to work with stateful workloads, I would recommend putting anything you care about onto a storage device, network attached storage or a SAN, and then attach that to your clients. And that way that data you care about is mounted on a safe external drive. It's got redundant RAID array underneath it. But I wouldn't recommend trying to persist state inside of Nomad. You can do a long running job if you wanted to. You can actually just say, just keep running. We're going to treat you like a normal VM. But if you think about the operating model of Nomad, it's not really designed for standing up a VM and caring, for it and feeding it manually here on and forever. Instead, what we do is we deploy from an image, as you saw. So that VMDK file now becomes your golden master image. And then we run workloads for a short amount of time until the next upgrade cycle. Maybe we just wipe our whole infrastructure clean and rebuild it every couple of months or every few weeks. That's what Nomad is targeting toward. So if you need state, either don't run it in Nomad or have network storage that you can trust and separate that from the stateless bit that runs on the app machine.
Okay. So now someone's asking, can I run something similar to Mesos Chronos scheduler on Nomad?
Maybe. I'll have to confess I'm not super deep in the Mesos Chronos world, but I can find out for you. Want to just reach out to me, or we'll take that question via email.
Okay. So next one, can you define persistent storage volumes in the job?
Inside the job? I think so. Yeah. I mean, I haven't experimented very deeply with the QEMU driver, but I'm assuming that anything that I'm passing variables through. So if adding persistent storage was a feature that your hypervisor supported, which QEMU does, you could certainly feed it the right variables. You might have to write some tooling, though, to provision the drive first. So I know that Nomad doesn't, it's not going to directly talk to your storage array and say, hey, give me a disk. However, if you're willing to do a little bit of tooling on your provisioning machine, for example, or your CI/CD system, you could have those things happen in steps, where we make the storage and then attach it to the VM that's running.
Cool. Okay. So we have a few more questions. So if anyone else has a question they've kind of been holding out on or thinking about, go ahead and submit it so that we get to it. Now, Sean, does Nomad support other VMware network drivers like VMX Net3 or Paravirtualized?
It's going to be limited to whatever QEMU will support. So we should probably just look that up. Yay, there we go. Cool. Guest support status. I would refer you to this page for answer on network drivers. But they've got a whole huge matrix of these are basically reports from users on what they've seen working. I would recommend leaning toward VirtIO if you're willing to do that extra step of installing the VirtIO driver. It is the main platform for KVM. And so it's trusted, and there's a lot of information out there on how to use it and how to get help with it. So on the VMXNet, I actually don't know. We could do one more search here. Yeah, someone's got something interesting. All right, requires further research.
Okay.
We'll look into that one.
Okay. Okay, two more questions, Sean. So
okay.
This one, so someone's wondering, is there a way to guarantee Nomad only pulls artifacts from a specific source?
Yeah, you can do that. So we have a tool called Sentinel. And I'll just show it to you real quick. Sentinel is our policy enforcement engine. It is an enterprise feature. But you can get very fine-grained rules about what you want to allow to happen. And so you could definitely use Sentinel to lock down, what images people were allowed to use and limit it to a very, restricted set.
Yeah, and maybe this is a good time, Sean, do you mind reviewing a little bit about the difference between Nomad Open Source and Nomad Enterprise? Sentinel's part of the Enterprise version.
Yeah, sure, happy to. Everything you saw in the demo is open source. These are the enterprise features. So the first one is namespaces. Here you can take a shared Nomad cluster and carve it up into namespaces, and that lets you partition your jobs and associated objects. So that way, an entire team could have its own, little space within Nomad, and another team can have their own space. And you can provide fine-grained access to everything. So that way, that everybody can share the cluster and not negatively impact the entire cluster when you tie it together with resource quotas. So this is multi-tenancy. It basically allows you to carve up your Nomad infrastructure into even smaller bits that you control. Resource quotas is another one. That lets you define quota specifications and tie them into namespaces. So think like a resource pool in VMware. This might be a similar analogy. Sentinel policies we just showed you. And then we have another tool called Advanced Autopilot. And you get some cool features like automated upgrades, enhanced read scalability. So you can add extra servers that are going to let you, have faster read times. And then you can do redundancy zones, which lets you have more servers than AZs. And that way, if you lose a voting server, Autopilot will quickly put that non-voter in charge. And that way you never end up, not never, but you greatly reduce the risk of losing availability inside of a zone. So mostly around, the enterprise features mostly center around the needs of large-ish enterprises. And that would be things like namespaces and Sentinel policies.
Yeah, awesome. Okay, thank you. And then final question. Can Nomad manage applications in multiple data centers or clouds?
Oh yeah, absolutely. Nomad has the ability to sync across multiple data centers, multiple clouds. You can even create Nomad clusters that span across hybrid environments. And that's got, there's some more information about that here on the Nomad page. We've got a little diagram here I can show you. Okay, it's actually on the Learn page. I believe it's under clustering. Okay, I'm not sure. We've added so much content recently, it's kind of hard to find stuff. But just to kind of describe it to you, you'll have a cluster, and you can have that cluster talk to other clusters. So they may be running in completely different data centers, and you could just specify that in your job spec. So up here at the top, I basically said, I want to run this in data center 1. Well, you could also run it in data center 2 or in, some cloud. You've got flexibility that way because the data centers are all communicating with one another.
Awesome. Okay, thank you, Sean. That was great.
Thanks, Amanda.
Thank you for powering through all those questions. As I mentioned at the beginning, this Hangout was recorded, and we will make the recording available on our website after processing. I will send an email out to all of you and everyone who registered with that link. I hope you all enjoyed today's Hangout and have a better understanding of how you can use Nomad with your legacy apps now. So thanks for hanging out with us today, and a big thanks to Sean for his time. That wraps things up for us. I hope you have a great rest of your day and weekend, and goodbye, everyone.